Hey everyone, this is my submission for the software internship at Diet. So in the GitHub repo, I have included the source code, all of the features I have built from the challenge, the tech stack, and I have also included the steps on how to set up the project locally. So if you wish to set the project up locally and test things out yourself, you can just follow these steps. So let me talk about the tech stack I have used. So I have used Node, Express and MongoDB on the backend and React on the frontend. And the reason I have chosen MongoDB as a database, I think choosing the database was the biggest design choice we had to make here. So I chose MongoDB because of its flexibility and potentials in horizontal scaling as compared to an SQL database. Also it supports nested objects, so that would satisfy this use case very well. So we had to build a log ingester and query interface. So the log ingester had to accept logs on port 3000. So my APIs are running right now. So this is a sample log. So if I send this log, it's gonna get entered into the database. So I'm gonna send this a couple of times. So the logs are getting saved in the database. So let me show you the query interface now. So we could create a CLI or a front end. So I decided to create a front end. This is what it looks like. These are all of the filters that we were required to build, and over here in this implementation we can add a single filter or multiple filters to query log data. If I don't add any filter, no filter would be applied and all of the logs are fetched. As you can see, these are all of the logs I have right now. Let's try applying. Let me also walk you through what these filters actually do. So these seem pretty self-explanatory. These level message also supports full text search. So if I talk about, let me take something from here. If I take something like connect to, and if I add filtering by message and I add connect to, it will give me all the messages that contain the phrase connect to. And if I go up, yeah, these are all of the logs that contain the phrase connect to. I've added full text search in messages, and if I talk about starting and ending time, let me take these timestamps that were mentioned in the challenge. So if I only add the starting time or ending time, it will only consider that timestamp and it will find all the timestamps which are equal to that. But if I enter both the starting and ending time together, it will consider it as a range and it will find all the logs that were started after this and before this. So if I filter it out, there are no logs with this timestamp. So let me just add the closing range, and then it will give me the entire range of timestamps. Filter by ending time and add the ending time. Now it would give me some logs. Yeah, so all of these timestamps are between this range. And similarly, I can also add filter by, let's say, what is it, trace ID. So if I add 1, it won't give me, oh, trace ID is 1, got filtered. So we can apply multiple labels, as you can see. So now let me talk about the scalability of what I've built. So I was thinking of using sharding, sharding to improve the write scalability and indexing to improve the read scalability. However, in this case, I don't think either of those are a good option, because if we talk about sharding typically involves we need to decide on a sharding key, right, on which basis we will separate the database into multiple databases, right? We need a key for that. But in this case, if we look at the logs, we want to be able to filter by every single one of these parameters. So if we want to filter logs by every single one of these parameters, it is very difficult to decide a sharding key. And whatever key we decide, and let's say we implement sharding and we divide the database into multiple copies, not copies, different databases, the search of the read speeds would be greatly increased because the databases are sharded, they're different databases now. So the read speeds would be increased, right? So we would be compromising on the read speeds. So I don't think sharding would really work. Sharding would work if we only had to query by a level or any one of these or a few of these, not by all of these. Talking about indexing, again, whenever we create an index, it greatly increases the write operation speed. So let's say if I create an index, we want to query by all of these, right? So to optimize it, we need to create an index on every one of these. If we do that, the write operation speed would get increased by a lot. And we don't want that because the logs are supposed to be a very, high, it is supposed to be a high volume of logs. So we don't want to compromise on the write speed. So that is one confusion I had. I think that is one confusion I had, and I don't think sharding or indexing is a good idea in this case. So that is all for my submission. Thank you.